Hey gang, welcome back. Okay, so what we're going to do today is we're going to sort of get started working on the memory blocks. You will remember from last episode, we had pretty much finished up memory pools. We're basically done with pools, and we're going to get going on the blocks, or at least get set up for it. Before I get into that, however, let me address what's probably the elephant in the room. Our last episode, I think, was in April. That sounds about right. And here it is, November. I wasn't expecting to be away quite that long. I knew it might be a little bit, but I wasn't expecting it to be, half a year. I can only plead that work has just been crazy this year. It has been absolutely insane. I manage a department, and our department is woefully understaffed, and we were just slammed all year, and there's no end in sight. We're gonna get slammed for a while, but you guys don't care about any of that. All I can say is I'll try to make this series a little bit more of a priority. I just haven't had time really to get into it, but regardless, I'm going to try to keep it going. So hopefully there won't be any more 6-month hiatuses. I can't make any promises. You never know what's going to happen, but I'm going to try to make this a bit more of a priority, even despite the fact that work is just crazy. It's been crazy, and it's not showing any signs of letting up as far as I can tell. Okay, so with that out of the way, I do apologize for being away this long. I wasn't expecting to be gone quite this long, but we're soldiering on. The series is certainly still going, so let's keep going. All right, I did try to record this episode almost about a week and a half ago, and it ended up being just a mess. And I went back and rewatched it, and basically went back to the code and undid everything that I did because I hated the episode. One of the trickier bits to this is not necessarily the coding, but getting to where we want to be. So the scrap code that I've got is actually significantly different from the code that you guys have seen, and so I know where I want to get to, but getting there from where we are is tricky because there's a lot to change. When I tried to do it last time, it just ended up being a hot mess. It was just all over the place. So I've organized my thoughts a little bit. I think we have enough material here for 2 or 3 episodes, or maybe even 4. So I've basically broken it down into where I want to get to today. I think I know exactly where I want to go today. So hopefully this is a little more focused this time around. So yeah. Okay, quickly, let's take a look at the code as it exists at the moment. That's not it. There it is. And what I want to focus on here for just a minute is not necessarily all this stuff, but let's grab the memory manager, the memory pool, and the memory block class. What have we got going here? Right now, in the memory manager class, we've got the default pool ID, the first pool, and the last pool. And I believe that's fine. Those are the items the memory manager class needs to function. We have a default pool ID. We're not really using this yet, but we will. And the first pool and last pool is our linked list, or is associated with our linked list. Not really. This is not directly associated. This just gets us to our first pool so that we can get to the linked list, and this gets us to our last pool so that we know where the last pool is, right? So we can add new pools as required. The memory pool class has several things in it. The aligned memory pointer, the original memory pointer, the name hash, prior pool, and next pool. Now this is our linked list right here for the pools. The named hash is fine because that'll get us from a string to a number, which is always better for searching. This I have a little bit of an issue with. And let me tell you why. So the original memory pointer, we need that. And why do we need that? Because you'll remember, let's see if we go back to Photoshop. The original memory pointer is sitting right here. Right there, right? So that's original. And why do we need to keep this? Because when we did the malloc, this is the address that we got back, right? And that's the address we need to do the delete or the free in the case of malloc. So we need to keep that, and that's fine. Then we aligned some memory. We found our first aligned memory spot, like let's say it was right here, and that's what we're keeping right there, this spot. And then this ended up being our class, or the header really. So when we initially started, and I talked about this early on in the series, we were going to use a header up in here to store a bunch of information, which is basically what we did, except kind of midway through, we kind of changed gears. Instead of really using a header in a traditional sense, what we did was instead we used a placement new to put the class here, right? Placement new to drop in our class. And so we're using this header not so much like a traditional header. We're using a class, which actually is better. Classes are easy to use, right? And we know how to use those. Headers are a little more difficult. Headers in the traditional sense, because you got to keep offsets to each piece of data that you want to access. And that is what we are keeping. Well, I keep hitting the wrong one. Right here with the aligned memory pointer, this bit right here. Now, in looking at this code, I realized that's kind of a holdover from when I was going to use headers, because we don't really need to use or keep that. If we want to access this particular piece of memory, this is exactly the same as the this pointer. So it's not really necessary for us to keep that bit of memory right there. We don't necessarily need it. If we for some reason have to access the address of that class, which I can't imagine why we would, but if we did, we could just use the this pointer, and that'll give us that. So we're really keeping some unneeded information there, and it's kind of a holdover from when we were going to use the header. So we're going to clean that up, I think. That's the idea. And I did it again. Gotta remember, it's the first one. So that's the one that I'm going to change, I think. And the memory block class is just a stub. We don't have anything in here yet. The only thing I really want to change is this one thing. But what we need to keep instead of this is a pointer to here, which I'm going to call, if I don't, let me make sure I get the name right. This is going to be called next available. Why am I not writing? Next available. Memory block. Ooh, that's terrible. Sorry for my writing. Again, as usual, it's hard to write on this thing. My writing is already not very good. And writing on this tablet is not that easy. Okay, so what is this? This is the aligned memory spot of the next available, right? So the next blank spot. So if we end up dropping in some memory right here, and let's see, we'll put a block in like right here. Well, I don't know what that was. Let's just delete that out and redo it, because that was terrible. Drawing horizontally on this thing's pretty easy. Drawing vertically is much more difficult for whatever reason. And I'm going to put in what I'll call the header. It's not really, we're going to use placement new again to drop the memory block class in there, just the same way we did with the memory pool class. And then here's your data, right? So we've dropped in the pool. Then we're going to recalculate this and move it over to the next spot that's aligned. And that's the key here. These are aligned. So the next one might be right here, for instance. See, there we go again. I told you it's difficult to write on this. That's going to make me crazy. Sorry, I know I'm being... And then that'll drop over to here, right? Should we put in another one? And so on. But the key is, we're always going to keep this available for ourselves as we add in new blocks. And it's always going to be aligned so that when we get ready to add in the next thing, we automatically have an aligned area. We know exactly where it needs to go. So I think that's what we need in here. Instead of using aligned memory pointer, what I think I want to do is just get rid of this because we don't need it. So yeah, let's get rid of that. We don't need that. And then I'm going to put in a void star. Next available memory block. Okay. And there you go. Now that's going to make memory pool class unhappy. So let's fix that because we've got this in here. So I'm going to take this out. So this, I think what I want to do is we'll rename this next aligned because we will set it up in the constructor to initially drop that in. So let's put that in here. Okay, like such. So I'm just going to clean that up a little bit. Okay. So we've got that set up, but we don't really have it actually doing anything yet, right? I didn't actually put this in yet. Before I do that, and I think we will do that today. I mean, I guess we could put it in, right? Next available memory block equals next aligned. That's easy enough, right? Right. I'm not setting, I have noticed, prior pool and next pool in the constructor. That's not probably very good. Let's initialize those to at least have something. That's what the constructors are for, right? So let's just do that. Okay, pretty good, pretty good. Okay. Now, let's go back to where we call this constructor, because we've kind of changed this right here into something a little bit different than what we started with. So let's go back to the memory manager class, which is going to be this guy here, and find where we added that constructor, which is going to be in add new pool. Here it is right here. Okay, let me take a look at what I did in my scrap code, because I want to make sure we do this exactly the same. All right, yes. A couple of things to take care of in here. Starting with this, because this is now a slightly different thing, right? It's not the same as what we were originally passing. Although surprisingly, it's not that different either. So yeah. Okay, let's talk about, well, there's a couple things I want to talk about. There's this up here too. Which one do I want to deal with first? Let's do this first, since that's what we're working on. Okay, guys, we want to make some modifications to this, because yeah, like I said, it's this this right here is slightly different than what we originally were putting in. We were originally putting in the address of the class, which is what that ended up being, and change it to the next address that's available for the next block. Before we do that, though, I need to switch gears just a little bit, and I don't want to. I'm a little bit hesitant to get too far into this, because I don't want to start jumping around like I did last time and getting out of focus. But in order to make this change, I need to switch gears a little bit and go off on a slight tangent. So bear with me. I think in a couple of places now If we look down at the malloc function, wherever the hell that is, where did we put that? There it is. We've got this calculation, this reinterpret cast, the offset, and then there's the negation, the alignment -1, all that sort of stuff. I'm going to end up using the same sort of calculation quite a bit, and I'm going to use it in the memory manager class, and I'm also going to use it in the memory pool class. I don't know that we're going to use it in the memory block class. We may or may not, depending on if we need anything aligned, but everything in memory block should be aligned already. While I'm here, actually, let's talk just for a second. And again, I don't want to start getting off on tangents, but I did want to mention this. We took this malloc, this malloc address that it gave it back to us, and we aligned it. Let's talk about that for a second. Malloc itself will align memory. The whole idea behind malloc and even the new function, is that they will align memory for you so that you don't ever have to worry about it, because it's kind of tricky to do. Now, malloc will align depending upon what you give it. And right here, what we're giving it actually is a size t, which ultimately ends up being a unsigned int. Now, an unsigned int, I think, will align to an 8-byte boundary. I could be wrong about that, but I think that's what it does. But malloc, yeah, I mean, if you put a character type in here, it'll align to a 1-byte boundary. If you put a float in here, it'll align to 8-byte boundary. If you put a pointer in here, it'll align to either an 8-byte or a 16-byte boundary, depending upon if you're in 32-bit mode or 64-bit mode. It just really depends on what you put in. Now, we put in an unsigned int, ultimately. I mean, they're size t's, but that's what it ends up being, is an unsigned int, which I believe goes to an 8-byte boundary. Now, that would probably work for us. I think we ended up, if I remember correctly, oh, we didn't set this out. That's right. So we ended up actually aligning to, where's my add class? There it is, or add pool. We ended up aligning to a 16-byte boundary right here. I'm going to talk about these numbers in a minute, or not in a minute, but a little bit later on in this episode. So was it absolutely required for us to realign this? Maybe. So malloc itself, like I said, will align depending upon what you pass it in. We are aligning to a specific place regardless of what gets passed in. So in that respect, actually, malloc is a little bit more advanced than us, because even if we put in just a character, it'll still align to our 16-byte boundary at the moment. Whereas malloc will align it to a 1-byte boundary, which is all characters need. So in that respect, malloc will actually pack things better than we would. We're not necessarily worried too much about packing things tightly together. So, which is why we've kind of done all of this. So yeah, I mean, is it absolutely, that's basically all I wanted to say. Is it absolutely necessary that we align malloc? It may not have been. 8-byte boundaries might work. I'm not entirely positive. I think a 16-byte boundary is absolutely almost guaranteed to work with pretty much anything, even classes. But anyway, okay, so that's enough about malloc and its inherent alignment things. The point of that was that malloc will pack things tighter than what we're going to pack them at. We're going to pack to, well, currently our 16-byte boundary, but we'll change that in a bit. Okay, but this calculation right here, I'm going to use this in several places, and I'm going to use it across different things. Now, one of our key concepts is called dry, don't repeat yourself. And I don't know how many times have I used this. Let's see if we can find out in this particular code. Find all. How many have we used this more than once? No, at the moment we're only using it once, but I promise you we're going to use it multiple times, and we're going to use it across different pools or different classes. Okay, so that being the case, now when you repeat a piece of code several times in a class, the idea is to abstract it out and turn it into a subroutine. But I'm going to use it across a couple of different classes. And when you do that, what you really need to do is abstract it out and turn it into an inherited class. So that's what we're going to do. So what I want to do here is we're going to go to project and add a class. There we go. And this is just going to be a helper class. Memory, let's call it memory helper class. Like such. Okay. What I want to do in here, we're going to make that protected, and we're going to make this equal to the default. And this equal to the default. So we're going to inherit this particular class into the memory manager class. So here, it's not coming up. Probably because I haven't saved it. Oh, also because I haven't put it in here. That's why. All right, that should make it happy. There we go. Okay, I'm also going to put that exact same thing into the memory pool class as well, wherever that happened to have gone. There it is, like such. Okay, because like I said, we're going to use it in both these places. And I'm not currently using it, and I may not end up using it in this episode, but ultimately I will be using it in this particular class. All right. So what we want to do is write ourselves a function to replace this line, basically, because this is fairly complex, right? And what do we want out of this function? We wanted to return a pointer, right? Because that's the whole point. We want a function that will take an address, find the next aligned address, and return that to us. So we're returning ourselves a pointer, and we'll call this calculate next aligned memory. So how's that going to work? We're going to take an original pointer, and we'll call this original. Original. There we go. And we'll take the alignment, and we'll use it unsigned int alignment. That's it. That's all we need. So we'll take the alignment, we'll take the original pointer, and we'll return the next available pointer that's aligned to that alignment, if that makes sense. Okay. Then we're going to, let's drop into here, and we can get rid of these because I already defaulted them. Do that. And do that. All right, there we go. And just because I'm OCD that way, I'm going to drop in my separator cloth thingy. Okay. Let's save that. All right. So this is this calculation is not dissimilar from what we're doing here. I mean, that's the whole point, right? So let's just take this as a start. Where did it go? There it is. So that'll be our starting point. And we could just return that directly, but I'm going to do some stuff in here, so let's do that. return aligned. Okay, this is erroring because this is not meant to be a pointer. That meant to be like that. There you go, that's better. Okay, I'm not going to go over this calculation in any great detail. We did it already when we set this up in the first place. So basically, it's the original pointer. We don't need an offset. I don't know. This is not necessary. You AND it with the inverse of the alignment minus 1, and that will, in fact, align the memory, but it'll align it backward, right? So instead of going forward into the next alignment, it'll go back into the previous alignment. That's how that. Why is this not working? Oh, because I got a plus in here still. Sorry. There we go. So yeah, like I said, this pulls it backward to the prior alignment rather than the current the next alignment. So in order to fix that, what we're going to do is just add back in the alignment again. So that just jumps it back to the next alignment, which should be in front of which should end up being after the original alignment, if that makes sense. Okay, so that's your calculation. We've essentially abstracted that out and basically returned the align. So what I want to do is make sure this is all working properly. So let's just put in a string, and I'm going to do this the old-fashioned way. The compiler doesn't like, I think. But we need to double check this, right? String comma. Let's give it the original location. And we'll drop that in. I'm also going to drop it in the same thing as, and I think it's capital X, as a hexadecimal value, because they're easier to track that way. And then I'll put debug string. It's probably not going to like that, and that's because I don't have in the, oops, standard IO.h. We'll take that back out later, but that should. It doesn't like output debug string. Probably because I need to include engine base in here. Because engine base should have our windows and whatnot, so that should fix that. And it does. Okay, good. So let's drop out our original location. We're going to test that. And then I'm going to do the same thing with the aligned location. We just want to make sure that this is working right. This is actually kind of critical that this works the way I'm expecting it. So we should check it. Aligned location. There we go. Okay, let's compile that and make sure that everything compiles okay. Yeah, it's going to give me a lot of warnings because it doesn't like. Actually, it's not going to just give me warnings, it's going to give me an error. Alright guys, let's just make the compiler happy. Alright, good enough. I mean, yeah. We'll use sprintf just because the compiler dislikes sprintf anymore. Okay. Okay, obviously that's not going to do anything yet because we haven't actually called it. Which we're going to do here. Okay. Yeah, actually, we're going to simplify this quite a bit. So what I'm going to do here is return calculate next to line memory. And what we need is the original and our alignment. That's all there is to it. Okay. Then I don't need any of this anymore. This is useless. Let's get rid of it. Right. So this I've changed. Originally what I was doing is I was getting the requested number of bytes, and I was also adding in an offset, which was basically the size of the memory pool class, plus its alignment and all that kind of stuff to add to it. I'm going to simplify that and take all that out. What we'll do is we're just going to sacrifice a little bit of space. So originally we had said if I wanted, like, say, a kilobyte, I would do a kilobyte plus this amount of space. I think what I'll do is I'll simplify by just giving it back a kilobyte, and we'll take up part of that kilobyte with our stuff. Otherwise, it just gets overly complicated. There's no real reason for that. So yeah, in fact, we don't need this anymore. We have the required bytes, so we have the alignment. We have the original. Yep, very good. That's all we need to do there. So you can notice that's a lot simpler. Let's go ahead and run this and make sure everything runs okay. Okay, it ran. It stopped. Very good. Thank you. Get out of here. I don't care about you. Okay. Oh, you know what I didn't do? Way back in the day when I used to program with Borland Builder, I spent many years in Borland Builder. The printf functions would automatically add line feeds for you, so you didn't have to worry about putting in line feeds here. And sometimes I forget because of that. Because I spent many years. I mean, it was a long time ago. Don't get me wrong. I haven't programmed in Borland Builder in 15 years. But I still often forget to put those in. So yeah, let's do that again. Okay. Let's see what we get here. We get crap because I can't tell the difference between a forward slash and a backslash. Okay, third time's the charm, guys, right? Okay, there we go. All right. Let's look at what we got here. So we malloc some memory, and it originally went here to this spot. We then, this is, by the way, aligned already according to the boundaries that we want. So with a 16-bit alignment, really what that means is that last number has to be, not that number, that this last number has to be 0 in hexadecimal. And that means you're aligned. Is that right? Yes, that's right. I think. Yeah, that's right. I have to think about it in binary. Yes, that is correct. And what we did is we jumped it. Remember, we jumped it forward. Now, the program itself is not going to determine if this is already aligned. So it just jumped it forward to the next one, which is going to be 50. So we were at 40, we went to 50. We could change that so that it automatically, it detects if it's already aligned and doesn't jump it forward. Should we do that? Let me hold off on that for now. I think I'm not sure if I want to do that or not. For the purposes of this, it would be okay, but if I already have it might be okay, but I'll have to think about it, because there could be situations where I want it to jump forward. So we're sacrificing a little bit more memory. I mean, we seem to be doing that quite a bit, but that's okay. So you can see it's aligned. That last number is 0. And then we've named the pool with this address, the aligned address. And you can see it's actually, malloc is, for whatever reason, putting everything at 40, which is fine. Okay, so it seems to be working, at least as far as we can tell. Let me talk about this for a second. Right now we're aligning to 16-bit using that magic number. Now you guys let me get away with using magic numbers in this function call. Let's fix that. That's one of the things I wanted to deal with in this episode. And I know we're jumping around a little bit. This is what happened with the prior time I tried to fix this, but that's because there's several miscellaneous things I wanted to get done in this, and it's kind of hard to not jump around a little. But all that being said, this in particular is a magic number. This one, not as much, although I could still fix it, because this is a true constant, right? What this is a conversion of kilobytes to bytes. It's a conversion vector. That is a true constant. So it's not that I couldn't change it to be less magical numbery, but it isn't as critical as this one. This is an actual magic number. So let's go ahead and fix that. Okay, yeah. For now, let's put it in engine base. I'm debating with myself whether I want to put it into the memory helper class or not, because that's basically where this is going to get used. But there's another part of me that thinks, well, if we put our magic numbers, or our defines really, in engine base, it'd be easier to pull them back out again and put them into somewhere where they could be changed by INI files, which is something we may do in the future. So for right now, I'm going to put it in engine base. So let's take that out. And I'll do a constant int, and we'll say memory alignment equals 16. Okay. Let's save that. And then we'll change this to memory alignment. There we go. Okay, this one. Yeah. I guess we could change it. There's a part of me that doesn't want to, but okay, let's let's change it. Kilo byte to byte conversion equals 1024. Okay, if you guys don't know about magic numbers, I'll go over it briefly and why I'm having a little bit of a tough time with this. Okay, so it is considered bad form to put straight numbers into a function call like that, because they're what are considered magic numbers. It's just a number that kind of appears out of nowhere, right? And the tricky bit of that is that if I wanted to change our memory alignment to something different, like 256 or 8 or whatever it might be, everywhere I called a line put or called this malloc class, I'd have to go through and find them all and change them. So instead, we're going to use a constant memory alignment, and I'm going to drop it into engine base, and then it's in one place. So if I need to change this, I can just change it here, and it'll change everywhere in the program. That's the whole idea, right? And also, 16 doesn't really tell you very much Whereas if I look at this, I can say align malloc. Our second parameter is a memory alignment parameter. It's very obvious what that is. So that's generally speaking why you don't want to use them. Now, having said that, I have seen people do things like this. Okay. Yeah, I've seen that happen before. And that's the result of somebody who was told while they were in college by their professor that using magic numbers is bad and you should never do it, and to change them to constants. And they took that advice, and it's good advice, more or less, but they did not really understand the concept. This right here, just because you've changed a number into a word, this is not giving you any new information, right? It's not telling you anything different. We can all see that this is the number 2. Calling it 2 doesn't help you at all. You're not really fixing anything by doing that. Now, this is perfectly acceptable, like say double screen size or whatever, whatever reason you're using it, because that tells you something about that number. It's no longer a number 2, it's twice your screen size. Okay, that tells you something about what's going on. This tells you nothing. That doesn't do anything for you. If you're doing that, it means you don't understand the concept of magic numbers and how to fix them. You might as well just put the 2 in there, the number 2 into your function call. And there are cases where it is perfectly acceptable to do that, where it's a true constant and you don't need to put this sort of constant in, right? This is a true constant, as opposed to this. This is a constant while the program is running, but it's not a constant during design time, because I can change this if I want to. So that has a very definite functionality to it. This has less functionality to it. The only real reason to change the 1024 into a word is to explain what this is doing. And we have done that. Kilobyte to byte conversion tells us something about the number 1024, right? It would also happen to be also like a megabyte to kilobyte conversion. And I suggest if you're going to do that, there's a temptation to use this incorrectly, but if you need to do that, my suggestion would be to make yourself a new constant to kilobyte. Even though they're the same number and these are basically equivalent, if you use this incorrectly to do this conversion, you're also not doing it right. So just don't do that. Make yourself a new constant that's going to tell you what you're doing in the program, right? Anyway, okay, so that's that little sidebar. Basically, I'm admonishing you guys because you let me get away with using magic numbers, and so you should call me out on that kind of stuff when I do stuff like that. And I don't remember the context under what we were probably coding a lot of stuff, and I just threw it in there real fast. Let's see what we got here. Yeah, I feel pretty good about that. All right. I want to make sure that this is doing, I want to give it a little bit more of a test. It's doing what we want it to do, because we really haven't fully tested this yet. Malloc is kind of already aligning this for us. And it should be aligning on an 8-byte boundary, so it could conceivably have a 7 in here. But for whatever reason, it's not. It seems to be putting it at 40 every single time, and I don't know why. It just happens to be that way. The internals of malloc are beyond my ability to understand. So yeah, just for fun, let's go ahead and change our memory alignment to 256 and make sure it works. Make sure it does what we expect. A 256 memory alignment should have 2 zeros at the end of the number when you write it in hexadecimal. So let's make sure this actually does, in fact, do what we want. So we went from 40, we went to 00. And it's the same number except it's 100 as opposed to a 040, which is the next aligned memory location, which is very nice. For whatever reason, malloc is insisting on putting the 040s. I don't know why. It just is. again, this could be any number really, with a 0 or a 7 at the end for malloking an unsigned integer. As far as I know, I don't think unsigned integers will align to 16-byte boundaries. I could be wrong about that, but I thought they were 8-byte boundary. I'm just curious what happens if we go into 64-bit mode. Make sure this works okay. I seem to remember we had some sort of warnings going on. Yeah, there's an exception. Okay. What's the exception here? All right, guys, I'll have to figure out what that is. Let's run it. Let's here, debug, stop debugging. Let's see if we get it again. Yeah, we sure did. Okay. Okay, we'll have to figure out what's going on with that. I'll do that kind of over the break. Let's go back into x86 for right now. That's too bad. I kind of wanted to see what was going to happen in 64-bit mode, but okay, we'll ignore it for right now. I'll work on that hopefully before the next one and see what's going on. I don't want to spend time trying to debug something that I have no idea why. We could be flailing about for a while. How are we doing here? Where are we at? Ooh, I've been going for an hour. Okay, guys. I think we're going to wrap it up for this one. I did not, in fact, actually get into memory block class stuff. We're still sitting at a stub. However, I think I will in the next episode. We're pretty well set up, actually, to be honest. We've got the next aligned ready to go. Dropping memory into that spot is actually fairly trivial. It's aligned, it's ready. It's, I don't have to actually go get any memory because we did that with the memory pool class. That's the whole point of it, remember? So we just really have to drop it in and then update the next align to the next spot. There's not a whole lot to it beyond that. We are going to use some linked lists in here to go from one memory block to the next. It's very similar to what we did with the memory manager class for pools. And let me just, gosh dang it, these things are all named kind of the same. So the memory pool class has our linked list. So eventually in the memory block class, we'll put that same linked list. Okay, that's going to be the idea. Other than dealing with the linked list, memory block class doesn't really have to do a whole lot. Okay, gang, yeah, pretty good. I'm pretty happy with that, I think. Everything seems to be working okay. All right, so yeah, we'll stop here. Hopefully next week, as long as I can find the time to record, we will start dealing with, I think we'll start dealing with the memory block class. We'll actually drop that memory in. I haven't entirely fully decided how to break it down into the next episode yet. There's still quite a lot of code that's in my scrap code that's different from what's in here, so we'll have to figure out what the best way to do that is. I'm just looking at code, guys. Sorry. All right, yeah, I'll stop. Otherwise, I could sit here forever and look at things that I want to change. All right, before we go, let me take a second to thank my patrons. My $5 plus patron is Michael Hilliard. Thank you very much. My $3 plus patrons are listed in the description below, along with any links that they've requested that I link to. So please do go check those out. And then finally, at the very end of this episode, you will see a list of all my $1 plus patrons. Thank you very much, guys. I really do appreciate it. This would be a much more difficult endeavor without your help. So yeah, thanks a lot. I can't say enough how much I appreciate it. All right, gang, we will stop here and we will pick this back up in the next episode. So I will see you guys in the next one. Thanks a lot. Thanks for watching, guys. If you enjoyed this video, please take a second to comment, like, and subscribe. All these things really help me out. I'd like to say a big thanks to all my patrons whose names are appearing on the screen right now. Thanks a lot, guys. I really do appreciate it. If you enjoyed this video and you'd like to see more great content, consider joining my list of patrons. There's a link on the screen in the bottom left corner. Thanks a lot, guys, and I'll see you in the next video.